All right, so rational exponent would be something like that. So the question would be, what does that mean? How do you deal with it? Right, because it's very common for us to see something like this. Yeah, this is the same thing. This is a root. Okay, so this would be the same thing as the cube root of 64.
Oh. Wow.
Okay. Anybody know what that is? 4. Yeah. So, because now if you study these in these relationships, 4 to the third is 64. So those two relationships will hold. So that's what a fractional exponent is, just a root. You can
so we just practice this for basically.
Let's see here. I want to use I'm trying to think of one real quick.
The one page.
So this is not going to look clean, but what's the difference between those two? So what is adding this 2 do to it?
Make it 6 squared.
Okay. Yeah, so it's still a cube root of 64, so now we're 64 squared.
Oh.
All right, so this top here is the exponent. Okay, the 3 is the root. So, okay, so this actually is a pretty good problem. So when you have a bigger number like this, do the root first. What's the cube root of 64? 4. 4. 4 squared is 60.
Gotcha.
So,
We
it's
would
not
have
really
to square it
showing.
before we keep that aside.
Yeah, 64 squared is a big number, right? So it's an indicator you probably want to make it smaller first. So use the root first if you can. So, okay, so that's the basics of a rational exponent. Using those within any of the properties we had yesterday. We'll look at something 81c to the 4th to the 1/4 power.
That is totally different.
Okay, remember so this is multiplication, right? So you can put this 1/4 on both of them. So 81 to the 1/4 and c to the 4th to the 1/4. You can do that. Remember not to do that if this is addition. Right. So those algebra atrocities off your sheet. Okay, so do you know 81 to the 1/4? What did you say? 3. Yeah, it's the 4th root of 81, so 3. And then c to the 4th to the 1/4. How do you deal with powers, exponent to an exponent? Multiply. So 4 times the 4th is 1. Okay. Nice thing about feelings, they can change.
Yeah.
So again, there's using properties that we talked about yesterday with the exponents that are rational. Okay, there are different ways to manipulate these. That one's not very clean, right?
Would you start canceling it?
So if we separate, this is, you can also write it like this, correct? It's the 6th root. Okay. So We have 9 to the 1/6 and x cubed to the 1/6.
It's 6.
Now, sometimes you have to, so what would that make this one?
X to the 13.
1/2. We use fractions. I told you decimals kind of aren't as useful as fractions are. So we know that is x to the root of x, right? Okay, so there's a simplified version of that part of it. Okay. Now simplifying these sometimes, if you have a calculator handy, not a big deal, right? Just punch it. You'll get a decimal. But sometimes it's useful to do something like this. So you simplify the base as much as possible.
So all you need is the exponent there.
So what's that? Sorry.
So 3 to the 1/3.
3 to the 1/3, which is the cube root of 3, right? So it's a little bit more of a simplified version. And it's not absolutely necessary all the time to do that, but sometimes it helps. So you just, again, using your powers properties, just go down through and simplify. I'd say this right here is something that trips people up sometimes. What you're trying to do is get it as small a base as possible. Small base as possible. You've probably already seen this before. What can you do with 2 square roots? They don't cancel each other out. Squared does.
Right. Multiply these roots.
We know this is true. Right.
Oh, you can just multiply them together.
Okay, you can. So what's 14 times 7?
92, 98.
Yeah, no.
Can you simplify that root? You can. Okay, it's easier to start here. Okay. So can I split 14 into 2 and 7, right? So we can combine them, right? What does that simplify to?
7 squared into
Instead of going through the 98 and down, you can just stop. Easier. So this is a good skill to have. Being able to simplify roots. Kind of like we've simplified denominators with roots in them. Being able to simplify roots is a pretty good skill to have. Are you aware of that? You can say yes just because I'm hurt doesn't mean you can't see it. Speak up. All right. Going back to something we did once already, how did you tackle that problem?
make the base smaller.
Yeah, okay, so let's do the 4 through to 625, and then cube it.
So what is that, 5?
Yeah, that's 5, which is,
125?
so again, there you go. Another example of a large number, root it first. If it's a clean root, it'll turn out pretty nice. You all know how to do these on a calculator? Roots.
Oh, wait, yeah. No.
Couple ways. Let me show you. gonna work. There you go.
Oh, what is it?
Okay, how have you put in exponents before?
So it's a carrot, right?
Yeah, so 625, and then, wait a second. Do your caret, and we deleted 3/4, right?
Oh, so we would do.
If you just want to do 1/4. So that caret key this is your key right there for
But
x.
there's no way to put something like in front of the square root thing.
If you want to, in the math menu, there is a root button that allows you to do cube roots, that allows you to do any root.
Oh, I see.
Okay. So if I did, let's say 1/4, then I went to math, it didn't work. So let's put it in parentheses. I use the exponent feature. I think it's easier.
Yeah.
You can use the root feature. Hold on a sec. Let me be intelligent here. We are not doing the fourth. We are doing the fourth root. That means I just need to put a 4.
Oh.
Right. Okay, so I think the exponent key is easier. That's personally how my mind works. But if you want to use the root key, good there? Okay. Try not to completely rely on that. Yeah, I know it's really easy just to type it in, but practice your roots like 3 cubed, 5 cubed, all those smaller squares and cubics. Try to do those in your mind, because there may be on a no calculator section of the test, of a test. How about something like this? Yesterday's properties with a rational exponent. Yeah, so subtract the exponents, right? And the answer to that? 4. The square root of 16, right? So 4.
If they were all
They are not all that easy, no. But again, follow your rules and know how to manipulate fractions. That's the key.
It's gonna be like a small problem.
Let's express. Okay, so this is just exercise in practicing simplifying radicals. Okay, can you make that into a problem that has rational exponents only? Or in this case, it'll actually be whole number exponents if they are rational.
4 times.
So cube root of 64. Yeah. How do you deal with that? Yeah, you divide it. There you go. Yep. And can you go the other direction?
What do you mean? That's what I'm.
So change that to something that looks like this.
What's the cube of the 12?
The 12 doesn't have any root on it, right?
Well, oh, never mind, that's a y.
So
But that.
the 12 is going to be outside anything. Can I make these the same root? Yeah, you can just get a common denominator.
Oh.
Okay, so if this is a 6, the 6 will be the common denominator. We have 4/6, right? And this will be 6. Right, so we have the 6th root of x to the 4th and y to the 3rd. So we just have a common denominator there. What? Why is that? How would you simplify that?
I'm still on the problem. Can we just put them all in parentheses and put it by 1/2?
That would not be more simple. Okay, do you know how to move numbers out of square roots? Now, can I move the even numbered ones out? This is to the 1/2 power, right?
Yeah.
So r to the 6th can move out and become,
R to the 3rd.
right, 6 times 1/2 is right, 3. 20 times 1/2 is 10.
2.
And what's left in here?
R.
It makes it a more simple radical. May not look more simple. That's what I'm thinking. Doesn't look more simple, but it really is mathematically. Because exponents are a lot easier to deal with than roots. Right. Think of the difference between something like 2 squared, which is 4, versus the square root of 2. Anybody know what that is? 1.414. Okay, so roots, exponents are definitely easier. All right, last item. Be able to solve equations with exponents in them. Okay. So let's solve. This is really the meat of our chapter, is solving equations with exponentials. Okay. So if you're looking at that algebraically, what do you think your first step?
So where do I have the answer? X equals 9.
Do you? Okay.
So you want to solve?
We'll log that one away and see if he's right.
Do we have to solve for x using the formula?
How do you know x is 9?
Because the 729 cube root is 9.
So there's a 4.
Fourth root.
Yeah.
Okay, do your algebra.
So it would be 4.
Right, so follow your algebra rules. Subtract 5 first, right? Okay, the question is how do you,
You flip that
Get
X,
you want to be x to the first, right? So how do you make, yeah,
you take the 3/4 and put it upside down.
so if I have 3/4 times 4/3, that's 1, correct?
Yeah.
And then what's 729 to the 4/3? You might have actually been right. Cube root of 729 is a 9?
Yeah.
Okay, what's 9 to the 4th? 729 times 9, 63.
What is it you read?
29 times 9. Yeah.
Nine? What's nine?
Still, less.
6,481.
It's 65, 61.
Oh, 9 to 4.
Close.
Oh.
Try again.
Try.
Because that might be round. Okay.
Are you gonna add?
6,560. Yeah.
There we go.
You ain't got no Mario on your calculator.
Okay, any questions there? Again, you have a lot of little things to deal with in this section. All the properties, all dealing with rational exponents, dealing with roots. It's a bunch of little things. Okay? So just take it one step at a time, like we do up here on the board, and you should be okay.
I like this.
Any questions? Good? Do you want me to write the word down again?
The same one.
Same as yesterday. I'll write it down, for there's some of you not here. I'll write it down again, but you have the rest of the hour to work. Please use that wisely. And I can certainly find other things for us to do. But I'd rather just be able to sit down. Because my hand hurts. I can't yet. Because I took some at 6. It's 8
Is that the
hours.
same homework you gave us yesterday?
It's the same as yesterday. It's okay to take Tylenol, but you don't want to take too much. You don't have any of that.
It works better.
At the risk of not being coherent, I will not take an opioid that's in my, don't even bring it.
I think that's the exact reason why he doesn't.
Oh my God. I'm on Paris
It's 10:05, right?
Yeah, it's middle 5. We got out at 33.
Mom's no longer my fighter.
Why did you tell me
I don't know where that came from.
It just showed up.
It showed up, well, I was kind of gone for a week, you know? Spent a few days in the intensive care unit, never helped. Kind of gone for a few days.
So where did you